Okay, let's continue. We're talking about integer data types. Last lecture we mentioned two useful types, integer and double. Note that most PCs are still 32-bit. That means that's the basic unit that the computer uses to work with. Although 64-bit PCs are now common. Remember, 32-bit means 4 bytes, and this is 8 bytes. This means that they are optimized for 32-bit integer values. An integer is stored as a string of 32 bits. Again, I'm not sure I call it a string. I call it a sequence of 32 bits, just because string makes us think that it's a character string. But anyway, as a string of 32 bits, or sequence of 32 bits, which is 4 bytes of memory. Now, the way they do this is the first bit is used to indicate the sign. So let's see, do we have an example? Going the next page. Well, what it's going to be is like this. This one is 32 bits. There are 32 spaces here. You can count them if you want. The first one will be used to indicate the sign of the number. So that is the number positive or negative. So maybe 0 means positive and 1 means negative, or vice versa. I'm not sure what it is, but we'll do some coding like that. And then we have, after that, 1, 2, 3, 4, 5, 6, 7, 8 are used for the exponent. So we have 8 bits to write the exponent. Remember, we said we'll write it, well, I'll look at it again, but 8 bits for the exponent. And then for the decimal part, we have all this, whatever is left over. Okay, so it's 23 bits for this part. This is called the mantissa. That's like the decimal part. So let's go back to that. So the first bit is called the sign bit, and that's used to indicate the sign. The remaining 31 bits indicate the number value. So we have the sign and the number value. Thus, an integer is in the range from here to here, and we need to store that in, 8 bytes, I think, whatever it was. Note, all 32 bits will be used regardless of the value. That just means just because you store a small integer as an integer, the computer still reserves the same amount of memory for it, whether it's a big integer or a small integer. The amount of memory that will be reserved is the same. For working with larger integers, the long type is also available. This is stored as 64 bits or 8 bytes. Longs are in the range from here to here, so it's much bigger than before. Where 2 to the 63 equals this, actually. So it could be minus this up to plus this. Okay, the short and byte types, those are two other types that we have here. Short and byte types are also available for efficiently working with small integers. So if you know you're only going to be using small integers, you can reserve less memory for them by declaring them as short or even byte. A short is 2 bytes in length, and that will, if it's in this range, if you're always using integers that are in this range, you could declare them as short. And then a byte is only 1 bit, and it's unsigned. So this one is signed, it could be negative, could be positive, but a byte is only 1 byte, and it goes from 0 to 255. Byte, I don't know if you can read this, but it says these bytes are mainly used for working with bit strings and for data transfer. So bytes are not usually, you don't usually work with bytes. Okay, next we have floating point data types. So I'll come back to that next.